Hi, guys. I wanted to take just a second to provide some feedback on homework set two. Okay. Um, I usually do that each week after I grade the homework. I know we're still getting caught up from the extension of that date from week one. So, as of today, you have already submitted week three. That will all be graded. Everything from week three will be graded by the end of this week. Usually you guys submit stuff and then it takes me about a week to get through all 100 submissions of things. But usually what I do is occasionally I will choose some really excellent examples of the homework questions, particularly on homework when we have to work through some problems like we did in set two, and share those with you. So if you have something on yours that I gave you feedback about that needs to be adjusted, then you'll have some good idea of what that should really look like, or what an excellent example or a distinguished example might be. Before we get into that, though, I do want to kind of recenter the mindset. Week two, three, this is usually where we come to sort of a time of reckoning in the class. And it's not unusual for this to be the place where teachers or teaching candidates, they really kind of get some cognitive dissonance going on in terms of the way they teach and the way they think about math. Now, ultimately, what does that mean? This is where I either see people really make a good turning point in understanding if they've learned procedurally what they've kind of missed out on by not learning conceptually. And most of those people are usually people who have struggled in math, not always, but most of the time, because I'll get the feedback, I wish somebody had shown me this, or I wish I had learned more. I might have been more interested that way. It might have made more sense to me. Most of my really strong strugglers, people who just really fought through math in their life and in their career, once they see this is sort of something they wish they had done about all along. I also will have my people who want to sit on the fence and say, well, I see it and I see how it could work, but there's just all these benefits to just procedural teaching. And then I have those who just dig their feet in and say, no, procedure worked for me, it'll work for anybody else. Here's what you have to come to the understanding of. Our book, our textbook, and even the things that I share with you, we don't share them with you because they're just my opinion and my opinion is the best. I don't share them with you because this is in a book and somebody wrote the book. The reason that this book that you have is the premier textbook, not just in the country, but in most all of education worldwide, as we're learning to teach conceptually, the Van de Waal book is considered a premier textbook for that, because it's not just based on Van de Waal and his collection of experts. This is based on a lot of research. It comes not just from research and practice of what works best from students, but also built on brain-based research and how people learn. So when we're arguing with the textbook, what we're basically saying is that, no, all of you experts and researchers don't know anything. I know better. Okay. So we do have to kind of think about that. And again, I'm not trying to tell you that your opinion doesn't matter. I'm just telling you that sometimes we have to broaden our thinking and we can't disregard what researchers and experts have to say. If we do that, that's a very dangerous mindset to get into as you go forth. In education, I taught for 15 years, all the way from elementary to high school to college classrooms, pure mathematics. I've taught subtraction and addition. I've taught calculus BC, okay, and everywhere in between. And one thing I've learned is that I'm always growing. I'm always learning. I also want to bring out that by pointing out how we can do better, that doesn't degrade what we've done. Okay. I have a lot of students who will say, oh, well, my teachers were just so awful because all they taught me was procedure. You have to really think about that. In education, we're learning more every single day and every single year. And many of us, when we learned math, procedure is what they were taught to teach us. That's how it worked. But here's the big kicker. In education, when we know better, we do better. That is what is expected of us. We're not expected to be perfect. We're not expected to get it right every single time, every single day, and be on 24/7. We do the best we can. But when we know better, it's up to us to do better. Okay, so that's kind of the point. We are all teachers and we want to do what's best. So we take it personally when we realize that something we're doing maybe isn't the best. So keep that in mind. This is not a personal attack, it's a way to help you grow. And we want to grow. That's part of being a good educator, is always doing better. So this is a homework submission that I have selected from a student who probably had consistently the best models for questions 1 through 4. And as you're creating your models, this is what I want you to think about. Most of us, especially if we are just attached to that procedural thinking process, we see modeling as kind of like an afterthought, especially if you're somebody who was comfortable with not ever thinking about why. To us, we did the procedure first, and then we threw in like the conceptual stuff later to kind of show what we did. Um, and that, and I say us because when I was a student, I learned procedurally. I'm almost 40 years old, so that was the way I was taught. And it worked for me. I could memorize very easily and I could produce correct answers. But it wasn't until I got into college and had to think much deeper about math that I really ran headfirst into a wall because I had no experience doing that. Thankfully, it was something I was interested in, I wanted to do. So I put the work and the effort in to make a difference. And we just know there's not a lot of kids who are going to do that. So what you have to understand is that when we're thinking about conceptual teaching and specifically modeling, which is what this chapter and this assignment was kind of focusing on, those models are not there to show what we did. They are there to help us do the right thing. Okay, now what is the difference? A lot of you this week, we also had the differentiation between the words memorize and recall. Okay, the difference between that is somebody who's memorized things, once you take away that memorization, they have no way to find the answer. Versus somebody who can recall things, even if they forget something, they have a strategy of how to get back to that answer. So these conceptual models, those are our strategies. They are our models for how to find the answer. I remember when I was in first grade, and we were learning, we had, some little addition and subtraction problems, and we were expected to procedurally or by memorization know the answer. Now, if we didn't, we could raise our hand and ask for counters. But most of us, even at 40 years old, I remember most of us saw this as a negative thing. If you had to have a counter, that meant you were not good at math and you couldn't do this. You needed extra help and that was bad. So by teaching all students these modeling strategies, what we're doing is we're taking away that stigma. We're trying to take away the idea that if you don't look at a problem and immediately know how to do this with a calculation, then you're not good at math. Okay? We're building people who can think through and make sense of math problems. The goal when you model is not to create an equation. That is not the goal. The goal is to give a concrete example of what is happening in a situation and help a student think through it. Okay. Now, my person who I've chose as my best example here, this person did set up an equation. Okay. Now, guys, first of all, in elementary school, we definitely, if we're learning addition and subtraction, that's a kindergarten and first grade standard. So we're definitely not going to use variables there. Okay. We are definitely not going to try to teach this as solving equations where we throw an X in here and then subtract 7 from both sides. This is elementary math. Okay. Now, I realize that in high school, we do sometimes solve equations like that. But when we're talking about how to solve these things in this class, because this is an elementary math class, that's going to be the students that we're focused on and the strategies we're going to learn about. Not that those can't be helpful with older kids too. Okay. So this person, what did they do? They actually stuck with the context of the problem. They didn't just use any counters, they used Star Wars action figures. Okay. So here, Ashton starts out with 7. Okay. And here he ended with 12. So what we want to know is how many did he buy? Okay. And many of you set this up as this kind of a problem. But it really doesn't just have to be that kind of a problem. I mean, this also could be modeling this as a problem. Okay, that also could be what we're looking at. So, again, instead of focusing on what this is, that's kind of irrelevant. It doesn't really matter how a student sets it up. We don't care about the procedure they're going to use here. What do we care about? We care about, can they look at this and make sense of the fact that I started with something, I ended with something else? That part here that I added has to be the difference between these two things. Okay. Now, if you were trying to give this word problems to students, I hope you would not want them using keywords here, because this is a problem where if you really don't think of it in context and what is happening, then this is going to be something that confuses students a lot. They're going to be ending up with a missing addend, okay, which is this kind of a setup, or a difference model and subtraction. Okay, either one of those can be appropriate here. But as a teacher, I'm not so much worried about that. I'm worried about, can you show me this situation in real life? And can you answer the question based on what you see? Okay, so this conceptual modeling here, when we're asking students to model, we're not asking them to do the math and then use objects to show us what they did procedurally. We're asking them to use the objects to think about and come to a conclusion. Now, once they've done that, that is a really excellent place for you to introduce symbolism, which is addition symbols, subtraction symbols, those kinds of things. Once they have a real life concept of what it means to do these things, that's when we add the symbolism on. Okay, that's the appropriate time for learning. So let's go on. The LOL dolls. Jessica has 14 LOL dolls for Christmas. Grandma bought 4 more. How many dolls are in her toy box? So here's what she has in her box. Here are the 4 more that Grandma bought. So we're going to count up those 4 places, and we know that there are 18 altogether. Okay, so that one's a little bit more direct. Again, we're not so much interested in this being written as an equation, although it's certainly an easy one to do so. Down here with number 3, okay, multiplication is something that students really struggle with, and I think it's one of the earliest places, other than borrowing and carrying, that we introduce procedure and just memorization in elementary school, and I think it's such a catastrophe at that point, because you have many students who can't memorize multiplication tables, and I mean, I could do that as a child, and it was easy for me. But when it came to actually explaining that to someone else, why is 3 times 3 9? Well, it just is. And that was my explanation when I was that age. But as I've gotten older and I've had students in my classroom who cannot understand what's going on, multiplication is repeated addition. And that is a relationship that if we model it properly, students can see that, they can make sense of what's going on there. So here we have Zahir, who has 10 red Lego bricks, and Malik has 3 times as many. How many does he have? So here we've got Zahir's collection. She's shown this, or my student here has shown this, and then shown 3 replications of that here. So we have a total of 30 blocks. Again, this was not your goal, although that certainly is what you're doing. I do think it would be easier for students. I know it's easier for students to see this model and then be able to translate that. Or even, that's not the only way they could show this problem. They could show it this way as well. Okay, so multiple ways. There's not just one way to get the right answer. So if you're teaching keywords, You're telling your student the only way this can be solved is by doing this calculation, and that's wrong. Okay. And you're also limiting their thinking when you're doing that. We all know, especially you guys know as special ed teachers, that students all think differently. So if we start out by teaching them with pulling out those keywords, this is the right way, they are immediately going to stop thinking in the many other creative ways in which they were doing because they want to be right and they don't think that can be right. So we're limiting them when we're not opening up that creativity. Okay. So this pencils question was one of the questions that I probably graded a little more harshly than you guys are going to be happy about. But I do want you to understand what's the purpose of modeling this. I had several of you who showed this problem by putting 24 of an object, the division symbol, and then 8 of an object, and then said equals, and then 3 of an object. Again, that is doing procedural math calculations and using objects to show what you did as opposed to finding the answer through manipulation of the model. Okay, so here we've got our classmates down here, and we've shown handing out one pencil at a time. Many of you said split the pencils, give each student 3 pencils. Now, you might have gotten some feedback. It's not that I counted that wrong. In terms of how your homework is graded, I encourage you to look back at the rubric that's in the syllabus, okay? That's what I always go by when I'm grading a homework assignment. So if you get something and you're thinking, wait, I didn't miss that many questions, go back and look at the rubric because it will match up with what your score is. But what I wanted here was to show each person getting 1 pencil at a time. That was perfect. If you showed them getting 3 pencils at a time, you're really already assuming that the student knows the answer before they've gone through the model, okay? Because how would they know not to give them 4? How would they know not to give them 2? Okay? If we're sharing and we're literally handing out 1 at a time until we run out, that's an authentic modeling of this situation, okay? So again, why does that matter? Why not just make them divide? Well, first of all, if they don't know their multiplication facts, that's not something they're going to be able to do. Okay. You're going to just sit there. They're going to be frustrated. You're going to be frustrated unless you give them a multiplication chart and make them go step by step by step of how to do it. That's really not beneficial in the long run. Okay. Because they still have no concept of what is actually happening there. Every time you can take a math problem, a story problem, and translate it into an actual action that a student can do or can imagine someone else doing, you made math fit for their life. You made a student at that point who's never going to say, when am I going to use this? Okay. It needs to be important. It needs to make sense. Okay. So let's keep going. When we got here to question number 5, okay, I want to give some general feedback about question number 5. When it comes to problems like these, when you're writing story problems, yes, we have some liberty to be creative in these. I used to write trigonometry units about my basset hound when I taught high school, and my students thought it was the funniest thing ever. I will tell you that was not easy. Trying to write an entire unit of trigonometry based on the adventures of an old stinky basset hound was not an easy task. But the students were interested in it, and I was interested in it. It kept me from being bored as well. One thing that's important as you write those problems, it's great to make them interesting, but make sure that the answers the students get will make sense. Okay, now what do I mean by that? Don't make the answer, if you're trying to find the height of a human, make sure that you've used numbers so that it doesn't come out to be negative. Make sure that you've used numbers so it doesn't come out to be 500 feet tall. Okay, make your solutions become realistic. And by doing that, you just have to watch the numbers you use. Okay, that's important. So for question number 5, it asks us to create 3 division problems and have these remainders end up in a particular way. A was to be discarded. Okay, now what does that mean? It doesn't mean you have to say in your problem, discard this. It just means you create a scenario where whatever is left over is not going to be used anymore. Okay. For example, one person created a problem where you were using ribbon to make hair bows. Okay, some sort of a bow to put in hair. I'm sorry, I have boys. I don't know anything about hair bows for little girls. But nonetheless, if I had 10 feet of ribbon and each hair bow requires 3 feet of ribbon, how many bows can I make from my 10 feet? That would be an example. We have to have a full 3 feet, so we're going to throw some away. We're not going to make half of a hair bow. That doesn't make sense. Okay. Many of you did good with A. You also did good with B. Okay, we want the answer to be a fraction. If I have 4 cookies, I have 3 cookies and I want to share them equally among 2 friends. Each one gets a cookie and a half. That would be a good example there. Where I saw a lot of the problem was with part C. And part C specifically said, you had to create a scenario where you would round up automatically. Many of you just created a scenario where you had a fraction quantity, but it was more than a half, and you thought, well, it has to round up. That's not what that means. The circumstances of the problem should dictate how we round. Okay, so this is another way that we can kind of know if we are thinking conceptually or if we are thinking procedurally. Someone who's thinking procedurally knows if it's 0.5 or above, I round up. Okay, but if we're thinking conceptually, that's where it goes back to the scenario we're dealing with. So a problem like that might be if my car holds 5 people and 9 of us want to go to the concert, how many trips am I going to have to make? Or if my car holds 5 people and 6 of us want to go to the concert. All right. If we were to do that division, we would not have a decimal point that would be 5 or above. We actually only have 1 person left over, but I still have to make another trip. Okay. So that's what it means by being forced up or forced down. It's about the circumstances, not the calculation. So what are we doing here? Even by writing problems like this, we're training ourselves to think about what's real, and we're teaching our students to think about what life actually looks like when we think about math. Okay, super important. Question number 6 specifically talked about keywords. Again, this is not a question, okay? It's not debatable. We know this to be true about keywords. Now, if you are trying to teach students just to do procedures, not to think about what they're doing, not to try to make sense of anything, every now and then a keyword will work. Okay? You will see the word times and multiplication will get the job done. However, that student has not tried to make sense of the situation. They hopefully they know their multiplication tables because they don't have anything to refer back to if they haven't read the scenario. Keywords is really a bad strategy to try to teach your students because you're telling them that the context doesn't matter, and that's a big problem. In addition to that, you're teaching them words that won't always be there. And unless you have created all the assignments and you've made sure it works out, while that might get that student a decent grade for you, what's going to happen when they go on to the next class where the teacher doesn't make sure that happens? When real life doesn't make sure that happens. Okay, our goal is not just to prepare kids to get an A on the assignment we give them, but to go on and do well once they've left our class. Question number 7 talked about strategies that you can use, okay, as you go forward. And many of you mentioned, that you didn't like memorization tactics. You wanted to have other strategies for teaching students that. The more story problems, the more authentic scenarios that students work through and perform calculations, they will retain that. It will stay in there. Now, is there anything wrong with doing flashcards and having those sort of things to practice your recall? I'm not telling you that students don't, it's not easier for students if they don't remember these. It definitely is, okay? But what we're doing by building these conceptual strategies is giving those students who are not going to memorize or who are not going to have quick recall with math facts or who haven't yet had a chance to build that recall of their facts, a way to find the answer. Okay, students have to understand what's going on. I mean, the first day that you and I learned about addition, we didn't know that 5 plus 2 is 7. Okay, so how are we going to figure that out if we didn't already have that recall? We're going to have some way of visualizing that, of counting it and understanding it. And that's what these strategies do. Okay, that's very, very important as we move on and we go through. So, again, I am not here to debate with you on whether or not procedural math is easier. It sure is easier to make a child rinse and repeat a task you've shown them or an action you've shown them. But do not be confused. When they're doing that, they are not demonstrating understanding of math. They are demonstrating their ability to watch you and repeat what you did. And that is not the same thing as knowing math. Think of it as speaking another language. You could tell me a phrase to repeat in your home language if it wasn't English, and I could repeat that phrase, but I would not know what I had said unless you told me. And I want you to think about that in terms of just procedural. That is what we're asking students to do when we're saying do this, do this, do this. Can they do it? Sure. Does it mean they know what they did? No. And if you're one of those students, probably when you hit Algebra 2 or beyond, that's probably where you started to struggle. Last year and all of the years before when I've taught statistics, if you know anything about statistics as a class, it's not a calculation class, it's a thinking class. And it's all word problems. I would have students try to mark out parts of the word problems, and then they would be frustrated because they couldn't respond to a lot of the questions. You have to think about the context. It has to matter, and we do have to understand what we're doing. And if we're not willing to teach students in that way, then we're setting them up to have a hard time in the future. If you are finding yourself where you know you need to do this, but it's very overwhelming, I tell people start with one topic. Pick out one topic that you teach and commit to teaching it conceptually. And then the next time, once you've got that down, the next time you've got, and the ability to do that, pick another topic. After you do that, a few years, you will have a great collection of conceptual teaching strategies. Okay? If you're new into the field, if you're getting ready to go into the field, start building that collection now. Okay? So that when you get to that point, you're not overwhelmed. You don't have to relearn things all at once. So again, if you have troubles, especially now that we're starting to work through problems, feel free to join me weekly on Zoom. If you can't do that, you're always welcome to email me or check in. Otherwise, I'm happy to take a look at something you've tried, give you some feedback on it. And if you have other questions, let me know. All right, bye-bye.